The RS232 BUS is a serial communication method commonly used for data transmission between PCs or between PCs and a terminal. The test and analysis of this kind of signal is widely applied. Our test board features an RS232 signal with a rate of 9600 bps. The data is Rigol DS6000, the frame structure is 1-bit start plus 8-bit data plus 1-bit stop, and the transmission sequence is LSB. The polarity is negative, and the even-odd check mode is none. Now let's have a look at how to use the Rigol DS4000 series digital oscilloscope to trigger and decode the signal. Connect the oscilloscope probe to the test terminal of the RS232 signal and ground the alligator clip. Press Auto, and the oscilloscope will adjust the time base and amplitude scale to proper values automatically. However, at this point, the signal is not stably triggered. Open the trigger menu and set the trigger parameters according to the signal characteristics or data content to display the signal on the screen more stably. Set the trigger type to RS232. Set the signal source to channel 1. Set the trigger condition to start, error, check error, and data. Here the trigger condition is set to data. Set the data bits to 8-bit and the data to 71. This is the ASCII code for the English letter G. Set the baud rate to 9600 bps, and set the trigger mode to auto. At this point you can see that the signal has stabilized. After the signal is stably triggered, you can select the decoding functions to interpret the signal information and display it on the screen. Press Decode. Set the decoding type to RS232 to enable the bus decoding function. Set TX to channel 1 and RX to off. Set the polarity to negative. Set the baud rate to 9600 bps. Set the data bits to 8-bit. Set the stop bit to 1. Set the even-odd check to none. Set the display format to ASCII, and adjust the transmission threshold to make it pass through the signal. The data content of the signal is now displayed on the interface while keeping all the other settings unchanged. The signal information is Rigol DS6000. Now we're going to adjust one of the settings to show what an error is going to look like. When the above data is triggered, we can change the check mode in the decoding menu to odd check. As the data on the demo board does not contain a check bit, you'll see that a red error mark is displayed. We can also adjust the time base scale to display more or less information on the screen. Note at a certain point the decoded data cannot be completely displayed. The decoding table displays the decoded data, corresponding time and error information on the TX and RX data lines in tabular format. It can be used to observe multiple transmissions and longer decoded data sets. Select Event Table and select On to view the 10 groups of data nearest to the trigger on the screen. If a USB storage device is currently connected, press Export to export the data table to the external USB storage device in CSV format. This concludes Rigol Oscilloscope RS232 bus trigger and decoding functions. The key points include selecting the proper time base and amplitude scale, setting the proper trigger conditions, setting the proper decoding conditions, and observe the decoded data information on the screen or in an event table. Thank you.